Two children play a game in which to kick a ball over a wall of height 1.5 meters, which is in this region here, which means the maximum height will be above 1.5. Assume the ball is horizontal, that the ground is horizontal, the ball is always kicked at 16 meters per second, and the angle at an angle of 45 degrees to horizontal. Find the maximum and minimum distances from the wall that the ball can be kicked in order to just clear the wall. Alright, this is an interesting question. Okay. So, if you imagine you're kicking the ball, alright, and there's a wall. You need to clear the you can clear the wall on the way up, or you can clear the wall on the way down. Okay, so there's two ways of clearing the wall. That's where the maximum and minimum distances come in. This is a good old question. Just need to expose yourself to as many of these like random questions as you can. Okay, the ball is always kicked at 19. Alright, and it's always kicked at an angle of 45 degrees. Is that correct? Always 45 degrees? Okay, so here's what I'm thinking. Phi x, Vy, Sx and Sy. That's what I'm always thinking. Okay, no matter what, that's where you go with these, right? So we're going for 19 over root 2, 19 over root 2. Okay, so we're going for 19 over root 2. That's just the speed. It isn't going to change because it's Phi x. Phi y is 19 over root 2 minus gt, or minus 9.8t. And then Sx is 19 over root 2 t, and then Sy is 19 over root 2 t minus a half, so minus 4.9 t squared. So a half at squared, which is half the velocity t squared, right? Now, we're going to have to start off with the sy value is 1.5. Okay, so the sy value is 1.5 is what we're dealing with here. Okay, so we have an sy value of 1.5, and what is the time it takes for it to reach a height of 1.5 is what we're going to figure out. Now there should be two times. There should be a time on the way up where it's 1.5, and then a time on the way down where it's 1.5. So we're expecting two times here, and I think that's what we're going to get. Bit of a messy equation if I'm being honest, but look, we'll give it a go. So I'm going to get 4.9 t squared minus 19 over root 2 t plus 1.5 equals 0. Now I'm going to minus b formula this. Nice, this is going to be grim. A is 4.9, b is minus 19 over root 2, and c is 1.5. Now I'm expecting two legitimate answers here. That's my plan, two legitimate answers, okay? These have not been nice questions for this late in the night, especially when I don't sleep. So let's give it a go. 19 over root 2. We'll go for plus first. What's it? Minus 19 over root 2 squared divided by root 2 squared. And then minus 4ac, so 4 times 4.9 times 1.5 all over 2a So 2 times 4.9. And that's a t-value of 2.6252. So t-value of 2.6252. Alright, let's get the other answer. Hopefully it works as well. Delete minus 0.1166. Now, the next question is, how far was your SX's when you did this? So this could be a green value. That's how far you could be away from the wall if you cleared it in the first value. Or you could have the blue value, which is here to here. That's how far you're away from the wall when you kick it. So there's two values. They're both SX values. So I'll try and use the SX formula. I'm hoping this works out because it looks nothing like the solutions. Looks absolutely nothing like the solutions. So 19 over root 2 times 2.6252. So multiply, and the other one is Sx equals 19 over root 2 multiply by, what's it, 0.1166. So I'm going to multiply this by 19 over root 2. Then I'm going to divide it by root 2. Yeah, 1.6 meters, round off to the nearest. So that is the correct answer. Sx is 1.6 meters. And then the other one, 19 over root 2 multiply by 2.6252. And then what do we get there? Syntax error. Awesome. Just trying to be lazy. 5.11. Now that one didn't come out the way I wanted it to. Ah, the 6.23 is on top. There's the error. There you are, 35.27. Take that all day long. Alright, happy days lads. There's your two answers for 3A.